Okay, we're going to look at momentum, and as you saw from earlier, momentum is actually used for its initial as AP. And so I think of it as momentum. That's how I remember that. So momentum is equal to mass times velocity, where mass is in kilograms and velocity is in meters per second. Now, that means my unit right here is kilograms times meters per second. And unlike newtons, a newton, kilograms times meters per second squared, there's no abbreviation. So I have to actually write out for momentum kilograms times meters per second. So there's no shortcut, no way around it. Okay, so as we look at this, we're going to do some actual problems with momentum. And remember, it's mass times velocity, right? Mass times velocity. So again, we could make a triangle with units and everything in it, where we've got momentum is kilograms times meters per second. That's my unit. And then we have mass, which is kilograms. And I'm writing this outside. If you make it bigger, you can put it inside the triangle. And velocity is in meters per second. So those units need to be, if you don't have a kilogram, you need to convert to kilograms. All right, so let's look at the first problem. Remembering where momentum is mass times velocity. So it's really just this first times a second. And if you take your handy dandy calculator and you take 0.04 times 19, you're going to get a momentum of 0.76, right? If you go down here, we could actually fill that in and put in 0.76. So that is how you are going to work those problems. It's simply the first column times the second column. 100 times 10 is 1,000, right? 60 times 20 is 1,200. Calculators are fine. You don't have to do it all in your head. You're going to do those 10. And then you're going to come down here and you're going to place those objects in orders from the greatest momentum on top to the least momentum on the bottom. So the bigger the number should be on top. So up here, you've got to come back now once you have all these on here. And if this is in the order you go, which has the greatest momentum, which has the biggest number, and that's how you're going to order these. And remember, ordering, you have to have at least 3 in a row to get right. So even if they're in the wrong place, ordering is a nasty thing. I should have made that fill in the blank, but you're going to do your best to try and get those in order. And then, do you think that these objects always have the same order? Well, no, because if they have the same order, that would mean they're never changing their speed. Because remember, as speed goes up, momentum goes up. As mass, volume goes up, momentum goes up. A Mini Cooper trying to stop is going to stop much faster than a Mack truck. Mack truck, especially if the Mack truck is filled, because the Mack truck has so much more momentum, it's going to take longer to stop. In other words, if you have a brick wall and a Mack truck crashed into it, it's probably going to take the wall out. If a Mini Cooper crashed into a brick wall, it may not take the wall out because the momentum is going to be different. So momentum can change if you change any of the variables. And then finally down here, you're going to say yes or no. Which of the following statements accurately describe momentum? If it's yes, it's momentum, then put yes. If it doesn't describe momentum, if it describes speed or describes acceleration, then put no. So we're really looking for just what is momentum.